Welcome. We've been taking a look at function composition, that is, taking two functions and writing one single new function from them by plugging one into the other. In this case, what we want to do is we want to take the single function f and then rewrite it as two functions being composed. So we have a function h, and we want to find functions f and g, so that way when we compose them, we get the function h. A natural question might be that of the domain. Are we worried about the domain of the functions f and g that are going to give us the same domain of the function h? No. So things get a little bit weird here. We might choose things that when we combine them, they actually result in varying domains. And that's okay. That's okay. All right, for our first example, we have x minus 1 cubed minus 17 times x minus 1 squared plus 2. In order for us to observe one function being plugged into another, the easiest way to do that is to try to observe that x appears in the same way each time. What I mean by that is, in this case, x doesn't appear alone. It appears as x minus 1 each time. So we have x minus 1 cubed, x minus 1 squared. Right? Those are the appearances of x. So my innermost function, the thing that I'm plugging in, is x minus 1. So if I wanted to identify the function f and the function g, g is the innermost function, x appears as x minus 1 each time. That's what I'm plugging into here. Now if I cover that up, right, x minus 1, what I'm left with is something cubed minus 17 times something squared plus 2. That something is x minus 1. And in the function f, I would just call it x. X cubed minus 17x plus 2. Now, just as a way to observe what's going on and verify our solution, we can find the composition. F of g of x is f of g of x. And that would be, we're going to take the function f and plug g into it. So g of x cubed minus 17 times g. Oh, that's supposed to be squared here. G of x squared plus 2. And what is g of x? Well, g of x is x minus 1. So x minus 1 cubed minus 17 times x minus 1 squared plus 2. So we have this function composition that gives us back exactly the thing that we started with. Okay, that's the goal. We want to do that a couple more times here. So for the function h of x, I wanted to give this example because it's slightly more interesting. We're not going to verify our solutions in each case because it would take a little bit too long to do that. I would encourage you to do so if you are uncomfortable with the functions that we have chosen. One of the things that I could do is very simple. Since I have this quotient being cubed, I can say, hey, look, I have this thing being cubed. Something cubed. So I could take my function f of x and g of x. I am plugging this quotient into the cube. So I have the cube, and the thing I'm plugging into that cube function is this quotient. Let's uncover that again so we remember what it was. That was x squared plus 2 divided by x squared minus 2. And this pair of functions works just fine. The other thing that I could do is more similar to what I did in the previous example. I could also say, how does x appear each time? Well, it appears as x squared each time. So I could identify f of x and g of x. G of x, again, is the thing that I am plugging in. So I am plugging in not just x each time, but it is appearing as x squared. So I have something plus 2, something minus 2, all being raised to the third power. And that something each time is x squared. So I could call it something plus 2 divided by something minus 2, and all of that is being cubed. And when I compose these two functions, f of g, I would get exactly h of x back. So these also work. I would encourage you to verify those, right? Evaluate the composition to verify that we get the same thing back. All right, now things look a little bit weird. What's going on? I have the square root of 1 minus the square root of 1 minus x. That's so weird. Well, the thing that I see repeatedly here is the square root of 1 minus. I have the square root of 1 minus something, and that something is the square root of 1 minus something. Huh. So I'm taking the function f of x, so I'm plugging this into that. I could think of it that way just fine. So I have the square root of 1 minus that something, right? That's my outer function, that something, and I'll just call it x for now. And what is that something that I'm plugging in? That something that I'm plugging in is the square root of 1 minus x, right? The thing that I've kind of boxed there. Oh, it's the same thing. I am just composing a function with itself to obtain the function h of x. Again, this will work. Feel free to evaluate that composition if you like, but it's just kind of a fun example that looks a little bit different than the others.